Hello student, the class is starting now. You must go to the teacher's website. Application of Python Artificial Intelligence in Business Forecasting. Today that I want to practice Chapter 6. The example of Chapter 6-3 using scikit-learn module with the 5 steps to build a KNN model to predict customer value in CRM. And first you should connect to our Google server and and uh, and then to read the data set, load the important CRM data set, the RFM customer value evaluation table. And first of all, that we should to read the file of this, and the data set of the file and the data table is like this. So I should to import pandas spd and to read the data for this as trend df trend, and I use this to read Excel. And then the data table is like the trend, and the data file name is like here. And I show the data trend data like here. But I must to split this into trend to x trend and y trend. X trend is I use df trend, and I split the RFM value, and the y trend that is for df trend, and I get the value of the customer value number, and I do to print out the y trend. And here that I have some data that is not correct, right? Oh, okay, here that I only have two 中刮虎. So here you see this is y trend, right? Okay, y trend. And I also must read the data set from the test. The previous data that is the trend data. Here of this is test data. So I import pandas spd, and I read of this as df test, and I read the file with the Excel file and the table. The table is the test, and the file name that is this. Here that is the df test. but I must to split the DF test into two two parts. One is X test, the other is the Y test. So the X test data is come from DF test, and for the DF test, that is RFM, and the Y test, that is for the customer's value index. So I also output the Y test. And for the second part, this is the practice tool. We have 5 steps for AI. First step is build a mathematical model, KNN model. So later that I want to build a model like this. This model is KNN classified model, and this model that is belong to the scikit-learn. They have a folder name label, and inside the KNN, you must to set up the number of the neighbor. Okay, we have, okay, if you do not to set the number, the default value is 5. So I write of this like this. I import the scikit-learn. He have a neighbor called, have a neighbor. I call this as a neighbor, and I use this neighbor to find if I have an algorithm. That algorithm is called KNN, K, K neighbors, but that is classified, not a regressor, because and the number of this is 5. And finally, that I create a model like this. And after that, I create a model like this, and I let this model to learn to feed the X trend and the Y trend. Okay, so now I use the model to learn the data fit. The data that I input that is X trend, and I also learn the value with the Y trend. I let it to learn, and then I make the prediction. Is that for a customer, when the customer the RFN value is 52 and 2100, you must predict whether the customer A is an important customer or not. So I want to make a prediction of this. I make a prediction of the RFN, right? X is two-dimensional, so I use the find 52 and 2000. So the answer, and I get the value is like this. The answer is 0. So the first one, right? So, but you know that I could not print out of this, so I can print out of the value like this. Oh, the answer is the 0, right? And then we'll do the practice 4. Evaluate the AI model's performance. The quantitative evaluation of model performance, we have three quantitative methods. The first is the use the overall accuracy, and we use the model's the accuracy score will tell us what is the model score, and the other one that is the model score. So we have two methods. We grade the model. Command 1 is the overall accuracy use the model score. The command 2 that is overall accuracy use accuracy score, and that is like here. So the first is model score. The second one is the accuracy score. So I write the command like this. Okay, the first I write the model score, and he said that you must input the x and the y, because that now we just to do the test, right? So we input the s test, and we use the y test, and finally he will tell you the score. This one is very correct. It's almost 1. And we have the second kind of method is use the overall accuracy, use the accuracy score. So let I import the scikit-learn, and inside scikit-learn we have a module that is matrix. I call this as MTS, and the MTS that I use it to do the prediction, right? No, here that I use of this, I find do I have an algorithm to uh, do the evaluation of the score? That is the accuracy score. And for the accuracy score, that we have the two parameter. One is one true, one is one predict. So that is one true. What is one true? Y test. And what is the Y predict? Predict that I do not know. So I must to calculate the predict first. The predict that is I use the model to do the predict. And the case that I do the predict, I use the Y test to do the predict. So finally, I can get the answer is quite the same. So both of this, the answer is the same. And then I do to do the practice file for the module evaluation, the second method, that is confusion matrix. And for the convention, for this of the confusion matrix, that is for any classification problem. A confusion matrix should be created. It allows us to visualize and the model's hit rate and the prediction rate of each sample category. Okay, so I must do like this kind of table. And for this kind of table, that here that we have the second method for evaluating model's accuracy, the confusion matrix. And for any classification problem, a confusion matrix should be created. It helps visualize the model's hit rate and the prediction rate of each sample category. The type 1, that is a confusion matrix. Okay, so now I must do like here. To do the import of the here this is confusion matrix, right? So that is inside the scikit-learn. And inside scikit-learn that we have the matrix, and I call this as MTS, and I use MTS to find do I have the confusion match. Okay, here this is my confusion matrix. And we have some example like here. Let us see the confusion. Okay, we use this. Confusion matrix. So inside the here of the confusion matrix, I think that I should use the confusion. Okay, here this is my confusion matrix. And inside the confusion matrix, that our parameter that is y true and y predict. So here that I use the y true, that is y test, and the y predict. So I must to do the y predict. I use the model for my prediction. Inside the prediction that I use input the X test. So finally I can get my this is my array. But I want to show as data frame. So I must to transfer array into data frame. Here that I use the pandas and PD data frame. And inside that file letter is any kinds of data. Okay, my data is this array. So I can output the data frame. But I must to tell somebody that for the index of here 0, 1, this is mean the raw data, the sample zin and the sample e. So I tell here that I tell for the index is like here. Sampling and the sample e. After I do that, here is 样本零样本一. And then inside here, I input the value of predict the sample and I predict. So the column of here is another one is predict 1, predict 0, and predict 1. So and the answer is like here. And here is how to interpret the confusion matrix. Understanding the correct and incorrect prediction. For the vertical analysis, that is evaluating the accuracy of AI model active prediction. Here that is the vertical prediction. For example, when the AI model prediction 0, that means it correct hit for the 15159 cases. This is the correct prediction. But for the incorrect prediction, we only have three cases like here. And for the AI model prediction, the 1, he said that it incorrect predict 5 cases. And it predict the 26995 cases. This can represent the AI model ability for prediction. For the horizontal analysis, It evaluates the accuracy of the how samples are predicted. For sample actually is labeled 0, that 1510159 were correctly predicted as 0, while 5 cases was incorrectly predicted as 1. And for sample actually is label 1, like here. The 3 was incorrectly predicted as 0, and the incorrect prediction rate, and the 2695 was correctly predicted as 1. Since this is just the table data frame, right? But and the second method that we use the illustration of the confusion matrix. Okay, so the command that is like here. I import the scikit-learn modules, and here inside that we have the module that is matrix, and I call this MTS. For the MTS that I have one function that is the figure showing the figure of the confusion matrix. That is you must to use the uppercase letters confusion matrix, and also to call for font prediction. Inside here that I should input the Y test. And also the Y prediction. And inside the Y prediction, I have the MTS, or I have the model prediction of what? Of X test, right? So the answer of that is like here. And finally, I have the practice 6, the second method for module evaluation. That is comprehensive classification report. Okay, I must do the report like this. So I just to do that, I import what? Import the scikit-learn. We have the scikit-learn. We have the matrix. I call this MTS, and I find if I have the classification. It seems the answer is like here, right? Okay, classification report. Inside that you should input the Y test, and the other one that is my prediction of to do some Y prediction, and the prediction over here is Y test, X test. And since that is a report, I can just to print out. Okay, finally that I get of this report. And the second method that is for evaluation the accuracy that I print out the confusion matrix illustration. So I use circular matrix, use this command, confusion matrix display. And for the from prediction, I input what test and what predict. Then I can draw the picture like here. So now I must to answer the question. The number of the sample labeled 0 is how much? Okay, it's 15159. That is 15159 plus 3 plus 5. The second question is number of the sample label 1. Is this total label, right? So that is called 3 plus 2695. And he asks that the total number of the sample. The total number of the sample is the 15159 plus 5 and plus 3 plus 2695. That is the total, right? So the answer is just like here, the total number of the sample. And here we have the vertical analysis. The data's accuracy is when predicts 0. Here that we have the data 0, prediction 0. When prediction 0, I must know the model's accuracy. Okay, here that is the AI models predict as 0 is the 15149 plus 3. So the total number of the model's accuracy when predicts 0. That is model's accuracy when predicting 0. So the accuracy is model 1, right? That is I use the model 0, not 1, prediction. So I want to calculate that this is the 15159 plus my prediction is 0, right? And the total number of that is 15159 plus 3. And the question 5, the model's accuracy when prediction 1. That is something divided by something. So here that is I predict 1. So the accuracy is this plus this to add to this. So 2695 the 5 that is 2695 2 3 plus 2695. So here that is prediction 1, right? So that is this plus not 3, that is 5. And for the horizontal analysis, that is passive accuracy. And the hit rate of the sample label 0. Here is my horizontal analysis. It's this direction. So he said the hit rate of that is the label 0. Label 0 is like here. So you can do the calculation. It said that for the passive accuracy, that is horizontal, right? Here that is okay. Label 0, so this is this direction, right? So that is 15159 divided by this 2 plus. So the answer that predict 1, how many number that is label 0. So label 0 is this direction, right? But he said that is horizontal way. 15159 divided by okay 15159 divided by something plus 1 15159. And the question 7 that is hit rate of sample label 1. Okay, student, you have 5 minutes to practice of this.